All right. Hello, and welcome to day 1.01 of ReactConf. So we made a few bug fixes since yesterday, but the public API, it's all the same. Restrooms, near the escalator, etc. So the changes we made were largely in response to the survey that we sent out last night. For example, we learned that the women's restroom has been playing Keeping Up with the Kardashians on repeat. So we're deeply, deeply sorry about that. It sounds really bad. There we go. Yeah, so it's important for us to know how we're doing. So you can kind of think of the survey as like our test suite, and your honest, constructive feedback is like a failing test with a good error message. So if you could take a moment to respond to the survey during the break, that would be really helpful for us. We'll try and address anything right away, and we'll continuously deploy new minor and patch versions of the conference throughout the day. All right, so our first speaker today is James Ide. He's often mistakenly referred to as James Ide. It's IDE, so I don't know. He's a co-founder of Exponent, which is also where I work, and his name is definitely one that you'll recognize if you've spent any time on the React Native repo. He's the most prolific contributor to React Native outside of Facebook, and he's the author of several popular libraries, including Xnavigator. So he's going to start us off this morning with a less technical talk about React Native and a bit about team building. So let's welcome him with some claps.
So good morning, everyone. Good morning. Hi, my name is James Ide, and I'm here to talk to you today about how React Native is actually ready for prime time and how that pertains to teams and technologies. So for a little bit of context, I'd like to tell you a bit about myself. I'm a core contributor to React Native with about 150 commits to GitHub, and I help with releases every now and then. By trade, I'm a software developer, and specifically I'm interested in libraries and systems for product development. I gave up frameworks years ago. My industry experience includes working at Google, Microsoft, Facebook, and most recently, Exponent. And I was really lucky to see the engineering org in each of these companies. And this shaped my own opinions on engineering teams, and this is what I want to talk to you today about. The other thing about my industry experience is that for most of my career, I've done web development, probably like many of you in this room here today. And it was only around about 2.5 years ago that I shifted my focus to mobile. And I'm going to talk about one reason for that change. So in the past few years, we've seen some very significant changes in technology, and I want to talk about two of those changes. The first and most significant is mobile. Think about the next billion computers. Not a million, that's not cool, 1 billion computers. Most of those computers are going to be mobile devices. And for many businesses, mobile revenue streams are growing faster than their desktop ones. In fact, some multi-billion-dollar businesses make more money from mobile than desktop. So mobile. The second change I want to talk to you about is React Native. On a technological level alone, React Native makes several profound leaps forward. And it makes these leaps together all at once. React Native is challenging conventional wisdom on all cylinders. But React Native's effect extends way beyond the code. React Native will change the way engineering teams are organized. So today, let's talk about teams and technology. First, I want to talk about React Native as a technology. Some of you don't need convincing that it's an awesome technology, and you know this. For the rest of you, let me tell you why React Native is awesome, by starting off with how empowering it is. Most of you watching this talk are web developers today. So I want to begin by contrasting React Native with the DOM. React Native has a much higher ceiling. And by this, I mean you can go further with React Native than you can with HTML-centric technologies. For example, want to embed an Apple or Google map arbitrarily in the middle of your view hierarchy? You can do that with React Native. Or a camera or an inline video player in the middle of your view hierarchy? Again, very easy to do with React Native. And you can do all of this today with React Native and ship it next week to all of your users. Part of what enables this is React Native's very extensible runtime. The ability to add native capabilities to the React Native runtime is very powerful. Who remembers border radius not being in every browser or Flexbox missing? We had to wait for spec committees to agree upon a standard, then for browser vendors to implement it, and finally for users to upgrade their browsers to the latest versions with all of those features. And after a couple years, finally we could reliably use Flexbox. With React Native, you can fork the layout system today and ship that right away to your users. Again, in 1 week, all of your users on your mobile app can be using your extensions to the React Native runtime. Mobile first. So React Native was designed from day one for mobile devices. React Native apps just feel better. It's a subjective thing. At Exponent, we talk about mouthfeel, how an app, the experience on a phone just can feel really great. And we found that React Native apps tend to feel great out of the box. They're more accommodating to touches and gestures. React Native components feel very responsive by default. But if you take a look at the most used mobile apps, most of them aren't built with the DOM. They're built with native technologies. So let's compare React Native with the Android and iOS native SDKs. App development is great with React Native. Obviously, it's cross-platform. You don't get this with iOS generally, and you don't get this with Android. There's a very fast feedback loop. So the window of time from editing your code to seeing its effects is significantly shorter than it has been with native toolkits. Edit your code, boom, your app reloads its JavaScript. And lastly, this is huge, continuous deployment. This totally changes how you think about your development process. JavaScript deployment is much faster and less disruptive than publishing your app to the App Store. Yesterday, we heard about code push, and we're fans of this idea at Exponent as well. And continuous deployment changes how people work. With continuous deployment, as a developer or a PM, you worry a lot less about getting your code in for the next release because you're always releasing. Mobile performance. So React Native is inherently multi-threaded, and this is critical for mobile. In fact, React Native uses 3 threads primarily: the JS thread, a shadow thread, and the native UI thread. And interestingly, it separates the notion of the UI thread from the main thread. In React Native, the main thread runs all your application JavaScript, and the UI thread runs all the UI native views that it would in a traditional iOS or Android app. This is important because mobile processors aren't getting that much faster. This equation here, which you don't need to understand the specifics of, but it relates power consumption, that's P, to voltage and frequency, V and F on the right. And generally with CPUs, if you want to increase the frequency, you have to increase the voltage as well. And if you increase the voltage, there's that squared term. So the power increases quadratically. So we can make our mobile processors faster by increasing the frequency, but then we drain our batteries and we increase heat output on phones. So instead, what hardware manufacturers have been doing is adding more cores. So being multi-threaded is great for React Native. And React Native is open source, and this is fantastic. It's open source in 2 ways: in a way where you can read the code, but also contribute back to it. You can't do this with iOS's UIKit at all. The code is completely closed source. And on Android, you can read the code, but it's hard to contribute back into mainstream Android. React Native's development is guided, and by this I mean the core contributors of React Native are actually using it in their own production apps that are important to their companies. This is huge. For example, at Exponent, we noticed our JavaScript animations sometimes stuttered a little bit. And so we worked together with Christoph Magera, who's another core contributor, to build stutter-free, off-threaded native animations. And we shaped that API and feature set based on real use cases, like an image gallery and a new navigation component coming to React Native that Eric Vicente shared with us yesterday. So if you couldn't tell, I believe React Native is a total game changer. But there's a big question in the room. You want to maybe use React Native, and so you're thinking about choosing it. And I believe choosing React Native is one of the most important technical decisions you will make. But that question is React Native ready for production? And I want to change this question up a little bit because different people have different views on what production ready means. So my definition for this is it possible to build solid, high-quality mobile apps using React Native? And the answer is yes. And I want to show you why we believe this at Exponent. First, just a little context. So I work on this product called Exponent, and it's a mobile app that lets you get and use things that people have made with React Native. With Exponent, you build things with pure JavaScript, publish your code to our servers, and then anyone with Exponent can use the thing that you built. If this interests you, we have a website, exponentjs.com, and you can learn more. And one thing I like to highlight is that the roadmap of Exponent is guided by real use cases. We want to understand the needs of developers, and we believe the best way for us to do that is to build real apps on Exponent, real apps that are high quality and going out to production. And I'd like to share two of these with you today. The first is called Brighten, and Brighten is an app that lets you make someone's day with a compliment. This is Austin, and I'd like to tell you about Austin's story. A few years ago, Austin's friend passed away in an accident. And in their grieving, his friends began sharing positive memories. And Austin wished his friend could have seen the outpouring of kind and heartfelt messages. Austin set up a compliment box. And people would anonymously write something nice about a friend and drop it in the box. People appreciated not just reading notes about them, but also writing the notes as well. Austin turned the compliment box into an iPhone app, and people started using it to brighten someone's day. But only some of their friends could use it. Remember, one of the problems with native technologies is that they generally work only on one platform. Brighten was for iPhone only, and we wanted to fix that. So we made a version of Brighten for Exponent. It's all written in pure JavaScript, and here's a screen recording of it running on a Nexus 5X. We've got a native feed, infinite feed. It's got variable height stories inside of it. You tap on profile icons. Screens pop up from the bottom, like you'd expect from a mobile app. Slide back down. Really nice. This is what users expect from mobile. We've got a contacts list. This is scrolling at 60 FPS. It's all React Native. Zero scroll jank. This is production, high-quality mobile experiences. You can jump between the sections, too. You got a scrubber on the side. So that's Brighten. I'd like to tell you about the second app, which is called the List app. On the right-hand side, we have BJ Novak, who is an actor, producer, writer, and was once a temp at a paper company even. One thing BJ did was keep a lot of lists on his phone. His favorite restaurants, movies he wanted to watch, and he wanted to see his friends' lists like this too. So to bring his idea to a bigger audience, BJ started looking into making an app about lists. And along the way, he was introduced to Dev Flaherty, who had helped lead user experience at Fab.com and had the background to bring the app to fruition. So they built it for iPhone. And the attention to detail in their iPhone app is great. Dev especially cares very deeply about the user experience. And the List app is very high quality, and it's really well built, and it set a high bar for its Android version. But again, it was iPhone only, and we wanted to fix that. So we made a version of the List app for Exponent. Pure JavaScript. And it taught us what we needed to improve about Exponent in order to build a complex app. If we could build List app, we could build a lot of other apps, and we weren't going to hit a ceiling. We've got an infinite feed with photos. Scroll down. We can tap into one of these lists. There's an image gallery. Zoom was a native animation that I mentioned earlier that we built for Exponent. Android back button does what users expect. There's a tab bar, lets you switch between sections. This is not a demo. This is a complete production quality app. Thank you. So I want to shed some light on this. How did we take React Native all the way to production to this level? By this, I don't mean simply publishing an app. I mean creating apps with the quality and complexity that people expect from mobile apps, regardless of the technology used to make them. Our users don't give us a free pass just because we're using a new technology. And one thing we learned is that React Native is only part of the story for success. And the other part was our team. I was really lucky to be working with some excellent people on Exponent and the React Native versions of Brighton and the List app. In yesterday's keynote, Nick Schrock described the characteristics of future mobile engineering teams. And so for the rest of this talk, I want to share with you the lessons we learned from the implementation, the execution of assembling an engineering team with expertise in React Native. Let's start with some of the personal qualities that we look for in an engineer that we found to be important. It is so key that your team members are open to React Native. This is really, really important because React Native is a new technology and it does things differently than HTML or native iOS and Android. At the same time, your team should be choosing React Native because they see its potential and not to shy away from learning native development. Because there's a certain quality of being unafraid to look under the hood. And this is so important with React Native. You want to be taking initiative. React Native covers a lot of surface area because mobile APIs are huge. Understand how React Native works. You will need to write custom components that work well with the architecture of React Native. And you'll need to diagnose performance issues at several levels of the client-side stack. You want people who can dive in and diagnose those issues or build high-quality components. In fact, one of the best pieces of engineering advice I've received is the code is the documentation. This is especially true with React Native for several reasons, and that mindset has served us very well. Sometimes you'll need to fork and modify React Native. We do it all the time at Exponent. The React Native roadmap, it may differ from your own needs. So by being proactive and able to address your own needs, you can take fate into your own hands instead of waiting for someone else to implement features or fix bugs for you. We also learned that experience with mobile or games is quite helpful. Games are interesting because of their tight resource constraints and emphasis on animations. They share some similarities with mobile. For example, reusing views is a common technique in game development and high-performance React components. But there was one thing that we found wasn't so important, and that was actually experience with React. People can learn React so quickly. So our lesson that we learned was success with React Native came from hustler mindset, not experience with React. With React Native, it's really valuable to understand mobile development. For many years myself, I did mostly web development, and it took me at least a year to become capable at mobile. The iOS and Android SDKs are ginormous, and for UIs alone, they each have their own system for views, gestures, rendering. The way screens are organized into view controllers and activities is different on each. They have different life cycles, adding even more complexity because you have to think about when your code is going to run. And of course, on mobile, some features are very easy to build with the native SDKs, and some features are very hard. So understanding those trade-offs, you get that from mobile experience. You have to be doing native mobile programming to understand, do I pursue building this certain feature with React Native, or do I just avoid building this feature at all on mobile because I just know the native capabilities aren't there? It calibrates your expectations. Similarly, mobile experience helps you critically reason about your app's UX and design. For example, a mobile developer is keenly in tune with the gesture handling that users expect. At Exponent, one feature we added to React Native is called hit test slot factor. This is a way to increase the hit boxes of buttons on the screen so that a user can comfortably tap them with their fingers without the precision of a mouse. This is something that you don't learn if you're doing only web development, specifically desktop web development. So understanding what the native platforms do is super helpful when developing apps with React Native. If you have mobile experience yourself, we want those of you excited about it and who believe in React Native to contribute back to the technology and push it forward. And if you don't have that experience, that's okay. But I believe you'll be most successful if you work with someone who does. They'll bring a lot of wisdom to the table. So our finding was that experience with mobile was more important than experience with web. Next, I want to shift to talking about teams. We talked about individuals, but now teams. At Exponent, people are responsible for work across both platforms. And lines of ownership are drawn between product features and APIs and not OSs. For example, one of our engineers, Brent, he built our image gallery for both Android and iOS. One person, both platforms. And at a product level, this meant that Brent was the owner of the image gallery, and he controlled the whole user experience. He made decisions about the design and how it should integrate. He chose how the API should look. He had agency to make whatever changes he saw fit. And we apply this to mobile APIs and infrastructure as well. Consider push notifications. There are slight differences in capabilities across Android and iOS. And by having one person take ownership of push notifications, we make it more likely that we'll create a consistent API across platforms. And as a cherry on top, since we use Node.js on the server, our engineers can work across stacks and up and down stacks. We want our product features, UI components, APIs to be coherent. And it's much easier to achieve that when one person is responsible for a given feature's vision. This is primarily for new teams. If you have an existing org that is divided into iOS and Android subdivisions, you can't make this change overnight. This is partly due to people reasons and partly due to technical ones. It will take time to build your cross-platform infrastructure and incrementally migrate your apps to a point where a reorg makes sense. So our lesson was that drawing lines of ownership between features instead of technologies encourages coherence across the platforms. And here we are. Up until now, we've heard of full-stack engineers who work at various levels of your software stack. I'd like to introduce the term cross-stack engineer. A cross-stack engineer is someone who works across stacks at the same level, notably Android and iOS. They have cross-platform responsibilities. One of the biggest benefits of having a cross-stack engineering team is organizational liquidity. And by this, I mean, how easy is it for people to switch responsibilities to satisfy their own interests and the needs of the team? And also, how easy is it for a company to reorganize its teams as needed? We found it's much easier for someone to go from implementing a newsfeed to an image gallery than it is to go from Android to iOS or vice versa. And one of the downstream effects of cross-stack engineering is that people can more easily relate to each other about technical matters. And this fosters a certain empathy, which is really nice. Of course, cross-stack engineering is challenging because the scope of the underlying mobile platforms is huge. And so my recommendation to you engineers watching this talk is to start with pure.js. You could try using Exponent, then gradually work your way out to both platforms. And trust me, at first, you will learn a lot. And with that, again, the hustler mindset is so important. You have to want to do this, and you want to work with people who are also go-getters themselves. With React Native, cross-stack engineering is this new opportunity that is blossoming. It makes so much more sense for engineers to work across stacks with React Native. This is new on mobile. This is a new era. So React Native is a really special technology, and its influence extends beyond our code bases. React Native improves the way we work as mobile developers. React Native is changing the way we organize engineering teams. And what's so exciting is that this tremendous opportunity is here today. React Native is ready for prime time, and all of us get to be the star. Thank you.
was some good thought leadership, defining terms on stage, cross-stack engineering. Good stuff. Okay, our next speaker is Gaëtan Renaudot. Works at Project September, and he knows a lot more about OpenGL than probably most people know about anything. His pinned tweet on Twitter says, OpenGL nightmares are all Y-flipped and alpha pre-multiplied. So like, I think it has the structure of a joke or something. I'm not really sure what it means, but maybe we will have some insight into that after his talk. So, Gaëtan.
Hi, everyone. I'm super happy to be here. So my name is Gaëtan Renaudot. I work at Project September, where we are building a React Native application for a fashion app. And we use React Native, we use Redux with GraphQL. Eventually, we will use Relay too. But my talk today is about using OpenGL and WebGL to make effects, GL effects. And I just want to start with this demo. We made this application actually to stress test a bit the library, to see if it works. And actually, we were quite impressed by the performances we reached. Like, the iOS version is running at 60 frames per second, no problem. And we have crazy effects like transition between images. We have transformation over the image here. It's even interactable. You can move the center of that effect. And we even have like effects over text, over views. This actually gets rasterized, so everything is expressed in React. It's a React app. The text is a text component, and so the library rasterizes that, inject as a texture, and we can do effects with that. Here's another more real-world example, like a real example, where we have defined it's like an image effects application. You can add like classical kind of effects, but even more advanced effects like this one. It runs with the same code base, React Native, so iOS and Android, and in the background, we even have a web version of that. Same code base. But let's see GL React. So GL React, basically, you can express using React components a blur, for instance, a blur over video with some negative color. You can compose. We all know how to use React, how to compose components. So we wanted to be able to do that over a video, over an image, over whatever. So composition. And we have actually two libraries. One is for React Native, GL React Native. So it wraps OpenGL. And we have developed also a version for DOM, which is on top of WebGL. And actually, these three libraries are mirroring a bit the React Native, React DOM. So GL React is universal, like React is, and we have the two implementations. So I really love React solves this problem to abstract the DOM. Like DOM is an immutable API, a mutable API, very like in primitive style, states everywhere. And thanks to React, we can express our app with like using virtual DOM. We can express at every time the full graph of our application, the full state, in a really functional way. And we have actually tried to solve the same problem on top of OpenGL, which is also like have states everywhere. It's quite low-level API, WebGL. So we've tried to solve that with something we can call virtual GL, so on top of WebGL and OpenGL. But what is OpenGL actually? OpenGL is defined as a pipeline. You have a series of steps that starts from vertices. So you have seen yesterday there was a talk React using in virtual reality. So you have seen how we can use vertices to define 3D shapes, complex shapes, and to make 3D, for instance. So we start with vertices, which are like points that get piped into a vertex shader, which will position on screen the points. Then we have a step which will actually make triangles out of that. Then it gets rasterized, so we have pixels, real pixels on the screen. And finally, we can color those pixels with a second step called the fragment shader. And finally, you have the blending, which will display things on screen. And actually, in GL React, we wanted to focus on the fragment shader because this part can be hard-coded. And just with fragment shaders, you can do a lot of things. I will show you. So the hard-coded parts will be actually 6 vertices that will be shaped as 2 triangles, just for covering the full surface. So we can color all pixels. But what is a fragment shader, actually? A fragment shader is just a function from point to color. For a given coordinate, x and y, you have to give a color, RGBA, and it's a really interesting paradigm that I like to call functional rendering. It's just a function. Let's see a bit the properties of this paradigm. So I like to say that it's unlimited because it's not limited to primitives like all classical drawing libraries. You don't have like draw rect, draw circles, things like this. Actually, for instance, to draw a circle, you have to think in a totally different way. You have to think I am in this circle, so for the given position, I am in this circle, so you have to use math. Calculate the distance between the center of your circle and your drawing points, and based on that, choose a color. This is how you draw a circle. Just functions. And what's really interesting is it's vectorial by design. It's a function you can run on 4 pixels, but you can run on any resolution you want. It's vectorial. And it's super efficient. This is the key point here. The GPU hardware have GPU units that solve very efficiently, can efficiently call the function on you can imagine it can split your rendering into different parts and run in parallel because GPU units are made for that. It runs in parallel super efficiently, and then back to the surface. And so you can process with GPU millions of pixels at 60 frames per second. It's efficient. Here's the first demo. It's like the hello world of OpenGL, basically. It's just a function from my point x and y, and I will just pass in x and y into the red and green components. Have the blue component are hard-coded, and it will just render that. So it's just like a 2D gradients, right? And how is it actually implemented in a fragment shader? This is the code that runs that. So it's a language called GLSL for OpenGL shading language. And what's a bit surprising here is that you don't actually see it's a function. Functional rendering, it's not a function. Actually, it is. So the input of that function is the varying here. It's a vector 2. So UV is your input, and your output is GLFrag color. You have to set this in the main function that will get called for each point. One important thing also to say is that the x and y coordinates are actually normalized between 0 and 1. So it's quite convenient because everything in this language is use this principle, normalized between 0 and 1. So you can just pass in things and it works. So let's look at a more real example now. I just want to display an image. So to do that in this paradigm, I have a function called texture2D. I give 2 parameters here. The first parameter is the texture, and the second parameter is the coordinates where you want to look up. So you want to look up in this texture at a given position. And so this will be run on all pixels, right? But this is just a linear mapping. I'm just giving back the same coordinate. So this is why you have just the image. But if you do more interesting stuff, like, for instance, squaring the x and the y, you will have this kind of deformation. So it's like UV time UV. You get the point. I can do anything on x and y and have a transformation out of that. So here I'm just using a bit of trigonometry, sinus and cosinus, and I already have a nice effect. Here's another example I've just written yesterday. It's just adding up 2 gradients together. So I have some built-in functions in this language. For instance, POW and distance. I can use them to combine, to multiply with colors, adding them up, and you can combine effects. If I just add one more gradient. So we can do really interesting stuff with that, in this paradigm, and people are doing crazy stuff on the internet. Can you believe that? It's procedurally generated in a function, with a function. It's like 600 line of code. One single shader to render this. And you know what? It's actually animated. So it renders like in real time on your computer, like burning a bit your graphic card, but quite impressive. Sorry. So I recommend you to go to these 2 websites. There's a lot of cool stuff out there. All right, let's go back now to GL React. So we have seen that we have uniforms. Uniforms are variables that came from the outside world. So in JavaScript, in our case, we want to be able to change, for instance, the blue. Just changing a bit our previous example, we have the blue that came as a uniform. I'm just passing it into the blue component, so I can have this animation. How can I define that in GL React? Actually, I just take this code, this shader, I put it in this code. So we have a create component function here that takes a function. It's like a render function, so you get props and you pass in it into a GL node. You can pass in uniforms, and that's it. That's what glues the React world with the GL world. And with that, with my component I've just defined, I can use it like this. And actually, to get a real rendering, you need to put that in a surface where you give a width and height. And surface can be imported from GL React Native or GL React DOM. So this is where you have our 3 libraries. What you put inside the surface is like universal, and surface is like contextualizing to the like either the DOM implementation or the native implementation. Okay, let's see how we can support textures. So textures are also uniforms. Here's an example where I define an inverse color component. This is the code that runs that. It's just like 1 minus the color, basically, so I have an inversion of color. I'm using children props, which is special props in React, so I can pass in it inside like as a children. Let's see how I can use that. Okay, so there's a bunch of cases. We can use it in many ways. First of all, I can just give an image, URL of an image. I can give a video, so we can do effects over a video. It's only working in the web at the moment. And I can even pass like anything in React Native, like a text, an image, and I will have an effect over that. But the most important part is we can compose things. I can take again my previous example, LGL, passing it inside this, like compose as many times as I want. So this is where it's powerful, I guess, where we can start composing things. And from this composition from this composition idea, we can start building interesting applications like this. So we have a variable blur here. My blur have 2 inputs, basically. We have the image that we want to blur, and we have a second image which defines where the blur is located. I can also move the blur around, can change the intensity of the blur. So yeah, we can do interesting stuff like this. Can you imagine doing that in CSS or Canvas? I don't think you can. I mean, CSS have filters. CSS have filters, but it's just like a blur filters, but you cannot go further than that. So this is a real world use case I had in my startup. So we wanted to have a text over an image where the image gets blurred just behind the text. So you can easily read the text. So this is where we have implemented like GL React. Let me show you quickly this. Can I switch? OK, it works. OK. OK, so here's the demo, quick demo. So this is like the effects. We don't see it much, but I can change the text here. OK, gets a bit. I forgot the M. We can use different images. And you see that the text is adapting based on the image color. So if I have a dark image, it will be white. Otherwise, it will be black. And we have some blur effects. And we can even put a video behind with the blur effects on top of it. OK. Good. So this is an example. How can we actually, like, I want to use this in my application. What can I write? This is just what you need to write, right? It's like an image title. We have a text. We have an image. So as a user, it's quite easy. OK, I have to contextualize that in a real, like in a surface to have an actual rendering. But that's it on the user side. Let's see how it works actually under the hood. So if you start actually using like React DevTools, you inspect this, and you will see that. So the surface is actually like rendered as a div. And there is two important parts in this div. So this is a container, and we have two pieces. We have contents, and we have the canvas. The canvas, like the WebGL canvas, is actually doing the real rendering. But we also need to, so if you pass in like a title, a text, we actually need to render that in DOM, right? This is why here you have the content. So title will render the text, and the canvas will render the effect. This is the code that runs the full example. So this GL component, the image title component, is split into multiple pieces. Let's see what are there. So first of all, we have the title rendering, which is provided by the title component, and so another component. In the DOM implementation, it's using a canvas because it's the only way you can get things in WebGL. But for the native implementation, we can just use the text for that. Then we have a second step, which is the blur map. The blur map is the image we've just seen to describe where the blur is located on the image. So we need to pass in the title, do something with it, and we generate this. Then with this blur map, we pass into a third component here, which will do the effect. So blur, a variable blur over the image. And finally, we need a fourth constant here that will give me the average color of the image, so I can based on that, choose the title color, either white or black. And finally, we can just pass in all our variables to the final component and have the rendering. Let's see how this component is implemented. It's itself another GL component. We choose another GL component. So we have two parts. We have a blur. We blur the title. And we have, like with a threshold, we will generate the blur map. And this blur itself is another series of steps. Blur is defined as it's a four-pass blur. This is an efficient way to implement blur. So we split the image on one direction, we split again in another direction, and this is how you can create blurs. So this is how it works under the hood. But because of that, so you see we have a deep nesting, and this blur map gets passed into blurv, which itself is a series of steps, like a multiple pass blur. So this results in a huge tree of components if we unwrap everything. And you see that it's not really optimized. We have 5 times the same things. We have 6 times the same rendering of title. But actually, we can improve that. We can share. We can cache, first of all, we can cache image. We can compute, if it's the same node, we can compute it once. And we can also render once the text. And so the job of GL React is actually to transform our initial user tree into actually a graph where duplicate parts will be factorized. Let's see how it works. So let's just take a simpler example. I have an ad, and I just want to add 2 LOGL together. This is what the graph will looks like. But if I just put that LOGL result, this virtual DOM element, into a variable that I use 2 times, I will actually have the node shared. And how this is working is just working by reference. if two virtual DOM is like strict equal, then we can consider the result of that virtual DOM to be the same. It's a nice property of a virtual DOM. So by this technique, we can factorize things, and we can move from this huge tree of 38 nodes, which take 20 milliseconds to render, okay, to this, which is 13 nodes and 4 milliseconds to render. So let's just quickly look at what it does. So we have contents. Just to summarize a bit. Gets passed into a series of blurs. We have our title blur map that is used to define the variable blur over the image. We also need to have the average color. So we just use two blur to squash on X all the pixels, squash again, and then we have only one pixel, which is the average color. It's a nice technique. And we can pipe that, and we have the result. OK, let me show you quickly this tool we developed to. So the tool I've used actually to make the graph image is actually a real inspector tool. Ooh. Oh, OK, it's here. I can just enter the inspector here. I can capture each step to see like what's going on. I can profile, see what the perfs are, like where is my bottleneck in this. I can even, OK, I will toggle back that. I can like profile in real time, like for the rendering. And what's interesting also is you can inspect what are the shaders used by each node. So the blur, one pass of blur is, this is how it's implemented. It duplicates the texture on one direction. And yeah, I guess the most important part is this one, which shows how this graph is actually, like, it's represented in a big object, which is here. And that's just what we need to actually render the scene, to render everything. And this object is what gets passed to the real implementation. So GL React solves the complex problem of turning this virtual DOM, virtual tree into this graph where everything resolved. And at the end, we can like just implement it in the implementations. Okay. So this tool is nice for the DOM version, but for the React Native version, you can just use systrace, which is really important stuff. I really recommend you to use systrace. It allows you to profile things, and we have support for that. So you can see what times each step of our graph takes. So this is just on 5 milliseconds. So you can see where is the bottleneck and everything. OK, let me wrap up a bit. So OpenGL, I like to say it's an ambiguous paradigm. Why I say that is because it's a sort of low-level imperative-style API, stateful, but also it has like really interesting functional bricks. And the idea here is that we want to hide the imperative parts and just keeping the functional parts. So you can implement universal GL effects. And what's interesting also is that just let people, defining these crazy shader things and exposing them on NPM, and then you can just use them and compose them. Everyone knows how to compose things. And finally, Virtual DOM has this nice property that it's referential transparent, and it's nice so we can use that to actually solve our problem. What's funny is that in React DOM or React Native, we didn't have this use case. Like you cannot even share the same DOM elements at the end. But in OpenGL world, it's quite important to not compute 2 times the same thing. So yeah, you can check this out on all these libraries. On NPM, we have a bunch of them, like the classical effects. And yeah, thank you.
All right. That was awesome. Yes, sorry about the noise back there. I like to jackhammer into concrete when I get really excited. So it might happen a bit more throughout the day, but we'll see. All right, we're going to take a break now, and then we'll come back and resume. That's what breaks are. See ya. Okay. Our next speaker is Jared Forsyth. Jared works at Khan Academy, but I met him back at React Rally in August when he was an intern at Facebook. So during his time at Facebook, he worked with the React team, and he actually rebuilt the React dev tools. So probably a lot of you are using his code somewhere. He also has a great blog at jaredforsyth.com. He writes about programming languages and techniques. So he writes about things like Rust and Go, ClojureScript, and reactive programming. He's intimidatingly smart and humble. So yeah, here's Jared. Please clap.
Hi. So, as he said, I'm Jared Forsyth. I'm going to be talking about managing app state in React. And this is what I look like on the internet. A little bit different, so you can recognize me. And right now I work at Khan Academy doing mobile development and web development. And we're trying to make it so that anyone, anywhere, can have access to a world-class education for free. A couple of important points about Khan Academy. First, it was founded in 2006, which, for reference, is when jQuery was first released. So that's eons ago in JavaScript time. And also, we have a lot of really rich JavaScript-heavy applications. And we're also a very early adopter of React. So managing app state in React is something that we care a lot about. So today, first, I'll start with talking about the problem, why I think this is worth giving a talk about. And then I'll talk about some of the current solutions. And I'll conclude with some recommendations for you to think about when you're addressing this problem in your own apps. So first, why is this a problem? Why is there even the question of how to manage app state in React? Well, when React came out, it was the V in MVC, right? It's just a library. It's not a framework. And we're familiar with MVC. You've got data. You've got a way to present the data, and then a way to manage the data. And we can't just not model or control. So some of us had large backbone apps, and we tried to fit React in there, in between the backbone models and backbone controllers. Other people had Angular or Ember apps and tried to do similar things. But it actually turns out that React is fairly opinionated about data. And that was one of the things that first attracted me to it, because React talks about state and props. And there's some data that you're allowed to modify and other data that you're not. And so fitting React in with a two-way data binding model or subscription model just kind of goes against the grain. And so pretty much since React came out, we've had this question of how to manage app state in React, especially shared state that's shared between different components throughout your tree. So React came out in 2013, 3 years ago. And a year later, the React team talked about Flux, which was the solution. It was the way to do app state. It wasn't a library. It was a paradigm. And pretty much ever since then, there's been a rush of libraries and methods explaining how to manage app state. So I'm going to talk mainly about Relay and Redux, with a couple of ClojureScript libraries thrown in for inspiration. The background for how I'm going to compare these libraries, we'll say we've got a little users table where each user has a color. And then we have a pure component that just expects to receive a color on the props and a way to change that color. So this pure component doesn't have any state itself. It doesn't know how to get that state. And the methods that I'll be describing are responsible for figuring out what state to give this component and giving it a callback function so that it can update that state. But first, I'll talk about how to do that in just React. Because even though React claims to just be the V, as I said, it has opinions about state. It knows about state. And you can model and control your data relatively well for small applications. And to set that up, you just have a root component that owns the state, and it has some methods to update that state. And then to get that data to our pure component, it passes the state down each intermediate layer to our pure component along with the update method so that it can update the state it receives. And this is what it might look like. You have get initial state, where our data just lives there, and then an update method that will take a user ID and a color and update the state for that user ID. And then in the render method, we don't have any intermediate layers, so we can just give the color for user 1 and a callback function that will just take a color and update it. And this works out great for small-scale apps, but it can get really cumbersome when you have larger apps, when you have lots of shared state. You find yourself plumbing the props down through all these levels, and it's easy to miss one, and it's hard to move things around. If you need to refactor, you need to replumb everything. And so that's why we look for another way to do this more formally. Redux is probably the most popular way to do this right now. It came out as the answer to the Flux question. Like, there were lots of Flux libraries, and now everyone only talks about Redux. And it's for a lot of good reasons. Redux has made some very specific design choices in addition to Flux that make it advantageous. But to set up, we have action creators and reducers that work together to change our state. And if you remember Lynn Clark's talk from yesterday, you'll have an idea of how this works. I won't go into it. But the action creator describes what we're going to do. We're going to update the color. And then the reducer takes that description and returns a new state so that we can effectively mutate. And in order for our pure component to get access to this state and the updater, there is a wrapper function that happens at the point where we need the data. So we just make a wrapper around our pure component that specifies a way to get the data we need from the global state, and it also passes in a callback function to update that state. Here's what the action creator and reducer might look like. We just have a description of a mutation and a way to handle a mutation. This second function looks a lot like the update method that we had in our plain old React component. There's not much difference here. And then to use that, here's an example of using the connect wrapper function, where we describe what prop we need. We need the color, and we can extract that from the global state. And we also pass in a function that will call our action creator. So the benefits of this: it's declarative. Each component is able to declare what state it needs and how to get that from the global state. You don't have to pass down all of this state through all of the props. And you can move a component from one place to another without worrying about having to replumb everything. It's also nice because the mutation logic, the way you update your state, is totally separated from the view. It's defined somewhere else. It's pure functions, and you can separately test them. And usually it's the updating of state that contains lots of really difficult logic that you want to make sure is fully tested, whereas the view logic is usually pretty simple. And of course, what you pay for this, for these benefits, is a little bit of setup, a little boilerplate. And for example, if you want to create a new action in the typical way of organizing a Redux application, you touch 3 different files. And if you're in a larger application where these benefits really pay off, you don't mind paying the cost. But for a very small one, it can feel a little bit cumbersome. At Khan Academy, we started using Redux in production several months ago when we were starting a new product that was for supporting local math learning competitions. And we had been using Flux before. We started using Flux a year ago on a different product and liked it, but this time Redux had gained general popularity, and we really liked the immutability of it and the easy testability of the reducers, and we found it's really paid off. There are still some state mutations that we found it's difficult to represent in the Redux model. Redux doesn't eliminate all complexity for you. There are still complex things, but it makes it easier to test and easier to think about. One of the things that we love about Redux is that the model is so simple. It's even simpler than Flux. And so it's easier to get everything into your head to realize how state will be changing in your app. Now, Reframe is a ClojureScript library that's very similar to Redux, and they're both actually based on functional reactive programming ideas, and they're both inspired by the Elm language. And so the action creators and reducers in Reframe are pretty much the same, but the big thing that it adds is subscriptions. Thanks for the hint. So subscriptions, in addition to defining the way that state is updated, subscriptions define how state is obtained. In Redux, you define at the place where you wrap the component how to get the individual bits of state. But subscriptions give a name to each piece of state that you want, and then that can be reused between components. And then at the wrapper component, you just define which subscriptions you want to use. Here's a little visual demonstration of how that works. In Redux, for the header, to-do list, and filter picker components, you might have a separate state to props function that at point of use defines how to get the state you need from the global state. Whereas in Reframe, you have these subscriptions, and then each component just uses one of those subscriptions. The benefits of this are that there's more logic that's abstracted away from the view layer. And these subscriptions can be reused between different components that need similar kinds of data. As well as subscriptions memoize their work. So if some part of the data changes, the subscriptions won't redo unnecessary work if their dependent data hasn't changed. And the cost of this, of course, is a little bit more complexity. The memoization can be tricky if you update your data in a way that it's not expecting. But in many cases, these benefits are more than enough to compensate. Relay, as you know, was released or announced last year at this conference, and then released several months ago. And it's the way that Facebook handles this problem. For the setup, you need a GraphQL server. And I won't talk about how to do that. That's a whole different beast. And if you already have a large server and database system, it can be a lot of effort to make it work with the GraphQL standard. But once you do, all of the queries are taken care of for you. For mutations, you still need to do some extra work, and they're defined both on the client side and the server side. And these enable some extra optimizations that Relay is able to give you. Using the state and updating the state is similar to Redux, although getting access is done even more declaratively by making GraphQL queries, which then Relay can use to get whatever state you need from the server, cache it intelligently, and then serve it up to you. And mutations are done in the same way as Redux, essentially. For setup, as I said, once you have the GraphQL server taken care of, queries are fine. But mutations are defined both on the client and the server. And this, you might be thinking, is this just to update a single attribute of the user? This is to change the user's color? I thought Redux had boilerplate. But I'll remind you that the extra work that you do for mutations allows many different performance optimizations, and that can more than outweigh the cost, especially for large-scale apps. The way to use this, the update function is very similar to Redux. You just create a mutation, and then the query defines what state the component is likely to need. In this case, just the color. Although you'll notice we also reference the mutation that we might want to make. Because the mutation, it's possible that it will also need data that our component doesn't need. For example, in order to mutate the color of a user, the mutation needs to know the user ID. And so that is specified in the fragment on the mutation. With Relay being a much larger solution, a much more comprehensive solution, there are many more benefits, but also you pay the setup cost. The benefits being that it's more declarative than Redux. There's no custom getter logic required. You can change queries all you want. And the GraphQL server takes care of all that for you. And the tight server integration between Relay and GraphQL enables intelligent caching, optimistic updates, and minimal fetching. And one of the best things from my perspective is that it will give you error messages at compile time if you have a query that is incompatible with your database. If you misspell an attribute name in the query, or you misconfigure one of your queries, it will let you know that you will have an error at production, which can give you a lot more confidence about the integrity of your system. The cost of this, again, you need to set up a GraphQL backend. Currently, it doesn't have a solution for state that only exists on the client and doesn't need to be persisted to the server. And there's also a lot more complexity involved because of all of the incredible optimizations that it gives you. And in order to enable those optimizations, there's a little bit less flexibility. There are some mutations that Relay can't do at the moment, and there are some ways of organizing your data that are hard to fit into the GraphQL paradigm. At Khan Academy, we experimented with Relay shortly after it was released. And one of our engineers redid one of our pages and created a GraphQL endpoint for a small section of the data. And it was really fun to play with GraphQL and see just the power and the expressivity of this query language. But in the end, we decided that the costs were prohibitive, at least for our case at that point. For one thing, setting up GraphQL for a small part of our database was OK, but to expand it to the rest, there were some ways that we model data that wouldn't have worked as well with the graph structure. And the endpoint that we set up was only read-only. And as I said, mutations take a lot more investment. OhmNext, you may have heard of. It is like Relay. It was inspired by Relay and Falcor and other things. And it's also in ClojureScript, which for some of you might be an advantage. For others, might make you want to stay away from it. I recently got into ClojureScript, and I love it. But it removes the dependency for a GraphQL server. And it is fairly agnostic about what server you use, so it's more flexible that way. It also has first-class support for client-only state, and it has custom query resolution. I'll talk a little bit about that now. In Relay, when your components have queries, Relay just sends that to the GraphQL endpoint intelligently with custom caching and all this. But in OhmNext, if you know a little bit about your state, and you know that one part of your state is, I need to refresh it all the time, I'll just send that directly to my dynamic endpoint. But another part of the state is never going to change. It's static. You can send that request to a CDN with HTTP caching headers, and the browser just knows how to do caching for you. And then if there's other state that only lives on the client, such as error messages or other things, it can take care of that for you. The benefits of the custom query resolution are that both client and remote state are fully supported, and it's also server agnostic. You don't have to rewrite or write a large wrapper on top of your current server in order to take advantage of these benefits, and it's very flexible. But the flexibility and less integration with the server means that it's much less optimized than Relay. There are some things that it can't give you, although it does still have optimistic updates, minimal fetching, and other things. And it's also still under active development, and there are many loose ends. In conclusion, some recommendations. First, have conventions about how you manage your app state. Regardless of what you choose to do, decide what you're going to do and stick with it. Because if you don't, you're going to run into the problem where just doing it with React is a little too cumbersome, so you have ad hoc solutions scattered throughout your app. And they're all different, and it gets much harder to reason about where your state is, where it lives, who updates it, et cetera. And one of the conventions I suggest you have is to use pure components as much as possible. So components that only receive props. They don't have any state themselves. They don't know how to get state. They rely on their parents to give them the state and also methods to update the state if they need it. And the benefit of this is that it makes it much more easy to swap out, to use a different app state method, management method, if you need it. If all of your views are pure components, then you can switch out the wrappers from normal React to Redux or to Relay and save yourself a lot of the migration time. And then as you're looking at these different things, just examine the trade-offs. They all have costs and benefits. I like to imagine them on two axes. On the bottom, we have the app size or complexity. This is wherever your app is. And then on the top, there's how much effort it will take. Effort can look like how much does it take to set up? What are all the moving parts? How much will it cost to maintain over time? And how understandable is the system? And app size isn't just lines of code. It can be team size. It can be your support expectations, and also what performance guarantees is your app required to fulfill. If we put React on here without any other libraries, it works fine for very small apps, but as you get larger, there comes a point when you can't take it anymore, and you need to switch to something else. So Redux might be that thing. It takes a little bit more setup. There's a little bit more boilerplate, but that really pays off as you get to larger, more complex app with more shared state. And then Relay has even more setup, but as you get to very large apps and things that you will be supporting for the long term, it can really pay off. When you're thinking about this question for yourselves, one of the things you need to ask is, where along this line is my app, and what should I choose? Thank you.
All right. It's lightning talk time. Yeah. Okay, our first speaker for this lightning talk round is going to be Devin Lindsay. She works at Apple, and she is an organizer of the React Meetup for San Francisco. So here's Devin.
This clicker doesn't work. Bravo. Okay, my name's Devin. Like you said, I'm Devin BL at all of the places. You can call me Devin, though you can skip the BL. Thank you. See, this is me. That's me. Hi. Like Brent said, I run the React Bay Area meetup, if you ever want to come to a meetup. And I am a front-end engineer at Apple by day. I write a ton of code. It's sometimes pretty okay code, but almost none of that code will any of you actually see, because if you were to pull up my GitHub profile, you would see I've made 0 upstream contributions in the last year, and I probably won't make any in the upcoming year either if my employment doesn't change. So I know, like, a lot of you in the room are probably making this face. Oh no! So this is confused emoji, like this. He's making this face. That's your face that you're making because you're like, oh, this is supposed to be an open source community thing where we're talking about contributing code and blah, blah, blah. But I'm here to tell you there are a lot of reasons why some people aren't actually contributing upstream to different repositories, even though we really want to. So why no open source? Everybody, why no open source? I find that those of us who aren't contributing traditionally fall into three main categories: those who can't, those who don't, and those who won't. Those of us that can't usually have some sort of legal thing around us. Our employers forbid it, or we have some sort of conflict of interest with a patent or a license. There's some sort of non-compete, some sort of contract involved. So those are the can'ts, right? But there's also the don'ts. Those are people who can't find enough hours in the day, or already contributing lots of hours and lots of code to their work code base. And so at the end of the day, they're like, I want to hang out with my family. I don't really want to write any more open source. And then there's, yeah, I know you're out there. There are those of us who just like have super bad imposter syndrome too, and we just don't want to put ourselves out there and like make ourselves vulnerable in front of this community. And mostly, I think there's a lot of us that are just lazy. And I think a lot of people who aren't contributing to open source, but using open source, are just at the end of the day, they're like, I'd rather eat pizza and play video games than contribute any more code to like the libraries that we know and love. But the third group is the group that won't, and I'm not sorry for bringing this up, but this community, while we use the descriptor of open, is inherently very divisive and exclusive. And while we want a lot of people to contribute open source, you'll notice on the issues and on IRC that the language that we use is very divisive and it's problematic. And there's a lot of hate speech against minorities and against women. And that inherently keeps those people out when they might potentially contribute more to open source communities. Thanks. So if you want to build a community, seriously? If you want to build an open source community, this is an open source community. You can see they're all contributing code except for the last one. He's playing video games. I would encourage all of you who have components, who have libraries, who have repositories, just enforce a zero tolerance policy against hate speech and divisive and problematic language, like no pejoratives, period. But if you are one of the few people out there who wants to give back to your community, but you can't write code, you should clone repositories, run them in all their permutations with different operating systems and builders and other sorts of software tools. Become really educated enough that you can actually open an educated, informed issue or contribute to documentation. Documentation is living. And we know that our software products cannot become any more successful if we don't continue to build a community that understands how they work, right? Yes. Also write blog posts, write instructional videos, like sing the praises. This is something that's interesting. I'm educated on it. Ask me a question. If you have extra time on your hands, I encourage you to start a meetup. They're needed all the time. Everybody's always seeking attention. I always have a wait list for my meetups, so more React.js meetups in the Bay Area would be fantastic. Come to meetups. The little microclimates of discussion that sort of happen encourage more open source contributions, encourage actual software contributions to happen. We come up with simple solutions to complex problems that nobody's actually talking about until they're stuck in a room together. And then most importantly, I think what all of us can do is just sing the praises of the software that we know and love, evangelize. Like, have you heard the good news? React.js is awesome. It's easy to use. It's well documented. Tell your mom, tell all your coworkers, tell Twitter. Like, just sing the praises. Any publicity is good for the software that we know and love. And also take pictures in front of Christmas trees. That's really important to open source. That's it. Thank you.
Don't worry, I got a napkin set up, so we're good now. All right, hi everyone. My name is Eric Sauter. I'm from Baltimore, where I work for a company called Fixed, and today we're going to have a retrospective on React Native. So I want to start by saying that I think React Native is awesome, and everyone in this room should use it. But the reason I lead with that is because my next slide, I'm going to change the title of my talk to React Native Sucks. But before everyone goes all Macaulay Culkin on me, I'm going to append to that it sucks a little bit. I have this really scientific pie chart here to illustrate when it sucks. So what we're going to do here is we're going to build an app in 3.5 minutes to see what I'm talking about. So Ben talked yesterday about the new project experience, and with React Native, it's awesome, right? You just have this one command, and right away you have a Bootstrap project, you have an app that's ready to go and start editing. It's awesome. All this great stuff built right in, out of the box, to make you insanely productive. So you can start building without worrying about configuration. In addition, you have all these components and APIs that allow you to just jump right in and start building your app. But eventually we're going to need more. That's not really a problem. We go to NPM. There's a ton of packages already to help us out. But because React Native is still, so things like video, Facebook login, a Stripe form, they're all there for us to use. But because React Native is still young, we're probably going to hit a point where we want to build something that no one else has done yet. So this leads to the ultimate realization of our worst fear, right, as JavaScript developers. We're going to have to jump into Xcode. We're going to have to know a little bit of Objective-C or Swift. We're going to have familiarity with the iOS SDKs. And of course, our favorites, these guys. So by this point, you're thinking like, man, this is kind of starting to get pretty complicated. There's a lot of stuff going on here, right? So we're probably going to need to read some documentation, kind of level up our skills a little bit. That's easy enough. We use Navigator iOS. Don't actually use this, by the way. But we're going to use it to change the background color. So we write some code for that, except it doesn't work. So what's going on here? Like, are the docs wrong? Maybe we need to update the React Native version. I had originally wrote that version docs would really help, like Ember has, but they now exist, which is awesome. But in our case, it looks like we actually need to upgrade React Native. So that's cool, but now we just broke something. Text inputs don't really seem to work anymore. Luckily, there's some great resources to reach out to. Here's some of them. But in our case, again, no luck. Let's try to open an issue. Yikes. That's a lot of issues. Some issues really shouldn't be issues. They're kind of just taking up space. And some others, and I'm guilty of this as well, tend to just stay open even when they're fixed and just add filler, really. And so the result is wasted time of the contributors and long-running issues and PRs that actually matter. This is one from September that's still open that I'm kind of waiting for. GitHub issue templates are a recent addition to GitHub that I think are going to be awesome to help reduce some of this filler. But I don't really have the time to read in all these docs and wait for issues, so we're just going to punt because we need to release. So that brings us to the App Store. As anyone who's used the App Store knows, it can be tedious, slow moving to get your app accepted. It's kind of a Hail Mary as to whether or not you're going to get accepted or rejected. Luckily, there's some awesome tools, some especially within the React Native community, that are trying to solve some of these problems with regards to update and deployment. And now fast forward to September, or back, React Native Android is out. So we'll have an Android out in no time because we have most of the code written. Not really. Repeat these slides, really, and then add some complaints about Android and Java, and you kind of get an idea about what your experience will be like. OK, so 30 seconds left. What's my point? This was kind of over the top, exaggerating a little bit, you know. First of all, like I said, I love React Native. It's completely changed the way we build mobile apps and allowed someone like me to just jump right in and be productive. I think we're spoiled by how awesome it is at times, and so issues can be exacerbated when they do appear. It's important to remember that many of these issues aren't unique to React Native, so we can look to other existing projects for solutions. If you're not contributing already, please do, because the more people that contribute, the better it's going to get. And please just don't complain unless you're going to offer some kind of solution. Because the fact is, it is getting better daily, and it's going to continue to get it better. So really, to summarize all this up, I just want to kind of, I guess, put like out a call to like, let's just keep identifying problems, building better solutions, and just making React Native more awesome. Thank you. That's my Twitter. You can check out Fix in the App Store and Play Store. Thanks.
Hi, everybody. I'm Adam Wolf. I'm an engineering director at Facebook. But today I want to talk about something I spend a lot of time thinking about, which is how we're going to build a reactive, live updating, distributed GraphQL server. Let me first illustrate like kind of what we're up against with the kind of problem that we face at Facebook. So I want to write a comment-like renderer for what we call the permalink page. You know, I tap on a status update and I want to see all the information about it. So in order to do this, I obviously need to know the original post, and then I need to get what we call the connection coming off that post for all the comments that I see there. And then I need to go another level and fetch all of the likes, which point to profiles for the people who've liked these comments. And this kind of two-hop data fetching is exactly what makes GraphQL so great and why we like to use it. But it also causes problems in the live update scenario. Let's just take a look at that. So someone comes along and likes the second comment, we add a new edge. And the problem that we have is that it's not enough just to listen to this top level, the root of our data fetching hierarchy. We also need to subscribe to all the intermediary nodes and find out what happens when they change. And this kind of problem, you know, like has never really been solved at scale in a distributed system. We can kind of imagine like using RX and observable for this kind of system, but I want to present an alternative. So I'd like to sort of think about this graph as a series of immutable updates, a log. So let me present kind of one structure that we could use to represent this graph. It's got 4 columns in it, and the first one is going to be a global time identifier. I'll talk a little bit about eventual consistency in a second, but eventual consistency is the reality in any distributed system, even though we can kind of try to gloss that over. So imagine this like an epoch time plus enough random information so that we can at least decide, looking at 2 entries in this list, what order they belong in, even if we find out about them out of order. Then we're going to have a type. These are either nodes or edges. This is a graph after all, but we can label these edges especially so that we can tell the difference between someone, say, authoring a comment and liking a comment. Then we're going to have an ID. This would probably really be like a UUID, but in this case, I'm just kind of using strings. And then we have some data associated with each one of these rows. For nodes, that's going to be a bag of properties. For edges, that's going to be more structured. It's an ID2, we call it, which is the thing that the edge points to. And then we have to remember whether adding or removing this edge because we have immutable data. We don't want to ever delete anything. We just want to append. So when we write, we're generally going to write down and add things to this table. And when we read, we're generally going to read backwards and read the most recent information first. Now, I call this sort of abstraction a stream. And, you know, I wrote a little class for this, tried to write something like Newsfeed, just a toy with it. It's a little cumbersome to use. I found it was a little easier to think about the different things that can appear in the stream one at a time. So let's take just the comment edges, for instance, in this stream and isolate those and call this a topic. And I call it a topic because it's similar to like an Apache Kafka topic or any of these log-based append systems that we're starting to see first used for data analytics, and I think we'll start to see them in production too. For a topic, you know, we can have a pretty simple API. And basically, even though we are going to have eventual consistency, it's really hard to program out of time order. So we want to present developers with a time-ordered API. So we're going to have a topic. It's like a generic class over some kind of data T. The constructor, we're going to bind that type that we saw in the table to the topic there. Well, for convenience, we'll provide an add function, although when we write, of course, we want one-way data flow. We know that from React. So that's just for convenience. And then we have this important interface that's called Memoize. And the idea behind Memoize is actually to produce the same kind of fake reactivity in this system that we have in React, right? Like that's what makes React so great, is that you get this kind of reactive update without having to worry about getting pushed an event that is kind of makes no sense, like delete something or change something. You know, really what you want to do is just get your data and render. That works super well in React, and I think we could make it work in a system like this. So for this interface, basically, I'm going to give you a function that takes an iterable over this topic. Again, I'm going to read it backwards, and produces a value. And then whenever I call the memoized version, I'll either get the last version, or if the data has changed, I'll recompute. So there are 2 things we need to build on top of these topics, nodes and edges. For nodes, we want 2 features that would be really great. One is partial writes. We don't want to have to read before we write, especially a consistent read. That would be really bad. And we also, as I said, want to support eventual consistency. So for, like, let's say we have a user profile and the user adds their first name and last name to their profile. And then later they update their age. You can see that I can add the age using this system without having to read the name first. The other thing is we might find out later that the user updated their name, and because of the way the topic API works, we sort of reorder these before we run our memoization function, and then we can produce like a memoized bag of properties for this node. That's pretty simple. Connections are the hard part. You know, if you think about React, this is like children getting rendered in a React tree. And we want some more fancy features here, like we want streaming tail load, so I want this ability to, like, as I scroll up, I want to load more and not load it all right when I start. I want reactive update, so if I add something at the end of the stream, that should appear there too. And then I also need memoization still, because a lot of times a connection represents a set and not an ordered list. So let's say we have a chat window, and chat's interesting because when I open a chat window, I need to go backwards in time and fetch historical data to fill the sort of up the window. But I also, of course, want to subscribe to events going forward in time. So how could this work in a system like Buzz? Well, what I'm going to do is, again, I'm going to read backwards, and when I step off the end of my list, I realize that I need to load more data. So I read again, and now I need to load more data, and maybe the system realizes that we need to page some in here. And then finally I read and I don't step off the end of the list, we know we have enough data. Now the interesting thing is that we can handle reactive update almost exactly the same way. We just write to the bottom, and now we read again, and we can fill the chat window up. So hopefully you see the parallels with React. There isn't a lot of time to develop this too much further. There's just a few more things I want to say before I go. I think, this is the beginning, and this is an open area that I think a lot of us are going to be working on for the next few years. Super exciting and interesting. Apps are getting more real-time, especially apps for the phone. I think we need to look more closely at broadcast-based network protocols. I think if we had realized the need for end-to-end encryption before we built networking, we might have broadcast-only networking. Like that, that's kind of my intuition about that. I also think probabilistic algorithms for distributing information, especially gossip and biased gossip, where we can sort of decide whether to transmit a message to a neighbor based on what we know about them, are really interesting. And finally, I think there are new network architectures that we can invent that will have much more better and more interesting scaling properties than what we have now. All right, that's it. Thanks a lot.
Hi, I'm Nicholas, and I'm going to talk about a project to bring React Native to web. In particular, I'm going to focus on a few web-specific things, styling and accessibility. So I work at Twitter on the mobile web team, and although we're a small team, there are lots of teams at Twitter building web UIs, and a lot of us are using React as well. So you might wonder, why am I interested in bringing React Native to web when React Native is kind of bringing a bunch of what's good about web development to native? But in short, I think the developer experience and the user experience that results from React Native is better than what you get with DOM primitives. And some of those DOM primitives are not really rich enough to be your go-to building blocks for apps. And in particular, there are issues with styling and code sharing when it comes to making sure that your components are styled when you're pulling things in from outside of your app. And so on web, you end up with either using class name, which has its problems because a string can have any number of styles attached to it, so you kind of lose control of styling. And it also requires you to end up using things like loaders or build tools or higher order components. So the current status of the project is that most of it's working on web. Some parts are in progress or slightly behind React Native because the project's moving very quickly. Some pieces are missing, notably the APIs that had undergone a lot of churn, like Navigator. And some parts, like the animated library, are just copy-paste straight out of React Native. But this thing works, and you can kind of build web apps with this thing. Most of the APIs are compatible with React Native. And in fact, it can run some of the React Native examples straight out of the React Native repo. So this is tic-tac-toe, like unmodified, running on mobile web. And this uses like 1.5K of gzipped CSS. This is the 2048 game, also straight out of React Native's repo, also running on mobile web. This is about 1.4K of CSS gzipped. And for Hack Week at Twitter, I took the mobile app that we're building with React and replaced all of our CSS modules, Webpack-based CSS, with React Native Web. And that took our CSS from 12K down to 2.5K. So those CSS bundles of like 1.5K and 2.5K are pretty small. But what's interesting is how little extra CSS is needed to go from styling a one-file tic-tac-toe game to styling our entire mobile app's 150 UI components. And the reason for this is because of how Stylesheet has been implemented to work on web. So although the API is compatible with React Native, and there's a couple of extensions to support some web-specific features, it ends up generating HTML and CSS that looks a bit like this. So what it does is it takes it takes in your style objects and converts each of those declarations into unique property value pairs. And then it takes those pairs and creates a unique CSS rule for each of them. And then the class that you get from it. So it completely avoids styling collisions and results in your CSS only growing when you create new unique property value pairs rather than just when you add more CSS to your components. So the style sheet itself kind of provides this automatic atomic CSS. You write CSS styles just like you would in React Native, and behind the scenes it optimizes it into this kind of minimal CSS footprint. It also has no build step requirements, so it just kind of works as you're working in something like JS bin or whatever. And it supports code splitting, so if you're asynchronously loading bundles in large applications like we do. And it supports universal rendering. So you can render this on the server with an extension I made to app registry, which is pre-render application. That returns a string of HTML and a string of your styles. And those styles are only the styles that you need to render the HTML that it sends back. So it's kind of like automatic, what's the word? Slimming down of your CSS to be exactly what you need to render the HTML in your app. In terms of accessibility, it maps some of the default accessibility props available in React Native to web equivalents, all these ARIA properties, and adds accessibility role, which maps to ARIA roles. And the main reason for this is because behind the scenes, we can use these roles and map them to DOM primitives that encapsulate accessibility features that we don't have access to otherwise. So it's really important for us to have accessible web apps. And so working with React Native, we wanted to make sure that the web equivalent was also accessible from the beginning. So in summary, it has this like novel CSS and JavaScript strategy that kind of results in this platform agnostic, build agnostic style API. And that really facilitates code sharing between teams because we don't have to worry about having common build tools to work with styles, and even potentially across platforms. So there's a few React Native modules that I pulled in and they just run, they just work on web because they don't use like Navigator and those kind of APIs. It also has some built-in web accessibility and support for universal rendering. So if you're interested in this, help me out. This is the GitHub link, and the examples that I showed are available on CodePen. Some of this, because there's so much of it that's copy-pasted from React Native, I feel like it might be worth moving into the main repo at some point if it seems like a good idea. And that's it. Thank you.
Hi, my name is Cole Voss. I'm a front-end engineer at Huddle in Lincoln, Nebraska. Yes, Nebraska. And I want to talk to you about learning other languages makes you a better JavaScript developer, something I feel pretty passionately about. So why learn other languages? So I Googled why learn other languages as if I was speaking about a spoken language. And a lot of the results were surprisingly they related to programming languages as well. Those were impress people around you. That's my favorite. Develop confidence. Improve your employability. Become more open-minded. Challenge yourself. Helping others in need. And what I find most interesting is to understand your own language better. So we're all JavaScript developers here. That's our language. And this was mentioned specifically in a lot of different results that I found, and this is kind of what I want to talk about. So what have I learned by learning other languages? So for a while, I was a Ruby developer on Rails mostly. And on Rails, you use a lot of CoffeeScript. CoffeeScript is pretty interesting, and it helped me really learn JavaScript because it looked like Ruby. It was a pretty graceful introduction to front-end development. And since it's white space based, I kind of became a freak about clean looking code. But it also introduced me into a lot of the new things coming out in ES 2015. And that was awesome because when I would read these new specs, I'm like, oh yeah, I use that in CoffeeScript. I don't use it anymore, but it helped me a lot. With Ruby, object-oriented programming, that taught me a lot about classical inheritance, variable scoping, how to write modular code, and I can take those things into JavaScript. C#. I'm not a C# developer necessarily, but a lot of Huddle's products are built on top of a .NET backend. I'd never seen a line of C# in my life until I started working at Huddle, and as soon as I had to jump into the backend and write a new API endpoint or fix something, I was terrified. But I ended up really, really enjoying it, or at least more than I thought, because I kind of like statically typed languages now. I like type safety. So bringing that back to JavaScript, I started to introduce better JS documentation, or even flow. And that made my JavaScript more understandable, more readable, and a little bit more error-proof as well. Haskell. Haskell's an interesting language. I've never written anything in Haskell, but I've spent a lot of time reading about it. I've read their documentation, I've read books about it, and what it taught me was what functional programming is. JavaScript did not teach me functional programming, but it can be used as a functional programming language. You can write functions that have no side effects or that are referentially transparent. So since, like I said, JavaScript isn't inherently functional, I didn't learn what that was, but with Haskell I did. It was really awesome. So I was able to take what I learned from Haskell into my JavaScript and think about things in a totally different light, and it really improved my code. Lastly is Clojure. Like Haskell, I've read a lot about Clojure, never really built anything with it. I really like it as a language though. Clojure, you might know, uses exclusively immutable data structures. So while I was learning Clojure and while I was learning about immutability, I was also kind of parallel learning immutable JS and how to use it and how to implement it in some of the things I was building. And that made learning immutable JS way easier than it would have been otherwise, because I knew about immutability from a language that is built around it. Immutable JS also uses a lot of functional paradigms. So taking things I learned from Clojure, Haskell, both purely functional, and immutability, I was able to use it almost more naturally than normal JavaScript data structures. So go learn other languages to impress other people, become more open-minded, help others, challenge yourself, become more confident, and most importantly for us, become a better JavaScript developer. Thank you.
Wow, yeah. I think Nicholas's voice almost like put me to sleep there. It was really, really soothing. But now it's lunchtime, so get excited. Same as yesterday, 2 doors there. You can line up. Right there, you can line up, and then we will come back and do more talks in an hour and a half or so. Thanks.